Now, let's review our current model. It's built upon this idea of more flow, more glow. If I look at two identical bulbs that were made at the same factory by the same worker on the same day, and one of them's brighter than the other, I can be sure there's more flow through the brighter bulb. The second principle is this relationship between the current through the battery and the resistance of the circuit. When one gets bigger, the other gets smaller. It's a trade-off. When the resistance gets bigger, the current through the battery goes down. When the resistance of the circuit gets smaller, the current through the battery goes up. Again, it's not what you add, but how you add it. There's two ways to add things. I can clutter up an existing path to increase resistance, or I can add a new path that didn't exist before to decrease resistance. When current gets to a branching point, it favors the path of least resistance. Say favors, not chooses. It's only in the special case of a short does all the current go the easy way. Usually you can just say more than half goes the easy way, less than half goes the hard way. And the final piece, the piece that we didn't get to on Wednesday, is the piece that we can't justify. It's just an observation. Branches that are parallel across the battery are independent of each other. I can hit one with a hammer, I can drive a truck over it. The other branch doesn't care. And that's our model. That's not just part of our model, that's it. That's the whole shooting match. Now, there's some subtleties, like when am I adding them in parallel? If you're adding things in series, well, let me ask you, are D and E in series, yes or no? Yes. Yes. Are A and B in series, yes or no? Heck no. Things are in series when what goes through one has to go through the other. Think of Fred, that electron you painted green. If Fred goes through D, he has to go through E to get back to the battery. No other path. But if Fred goes through A, does he have to go through B to get back to the battery? No, he can go through C. So what A is in series with is not B, it's not C, it's the parallel network of BC. I would say that A is in series with the parallel network of BC. If Fred goes through A, he has to go through that network. Now, things in series have the same current, not just the same value, but the same current, the same Fred and his friends. It flows through one and then it flows through the other. And we need scissors to add something in series. Unless we're doing it at the whiteboard, then we can use an eraser. Okay? When we add something in parallel, at the junction, Fred's got to choose, do I go this way or do I go that way? For example, B and C are parallel to each other. If Fred gets here, he's got to decide, do I go through B or do I go through C? Likewise, would I say that A and E are parallel to each other? No or heck no? Heck no, okay? It turns out that what's parallel is this and this. Things are in parallel when you can find a direct connection with nothing but wire on both sides. Okay? And so this network of D and E is parallel to this network of A, B, and C. Fred has to choose. Do I go through this network or do I go through that network? The networks are what are in parallel with each other. Likewise, B and C are in parallel with each other because you can get a direct connection with nothing but wire on both sides. When you're adding something in parallel, you can just clip the new stuff on with alligator clips. You don't need scissors. You don't need to erase anything. So if I wanted to add something in parallel, I just come out and add it. I didn't use my eraser. Okay?